Hello, my little mathematicians. Today, we're going to talk some more about how to use ratios to solve word problems. And more specifically, we're going to talk about, if you've heard the term, what a proportion is. Okay, so a proportion is an equation that states two ratios or rates are equivalent. So we know that 1/3 is a fraction, and we've discussed that a ratio is basically a type of a fraction, right? And we know that this is another fraction or ratio. And these two ratios are equivalent because 2/6 can reduce to 1/3. So these are called equivalent ratios. Now, if I just set these two ratios equal to each other, that's called a proportion. Okay, so we've kind of already been doing this, but now you can see that when we use the term proportion, that's all it is. It's two ratios set equal to each other. So for instance, if I had this problem right here, okay, Sheldon and Leonard are partners in a business. Sheldon makes $2 in profit for every $5 that Leonard makes. If together they make a profit of 28 on the first item they sell, how much profit does Sheldon make? You know, this one's a little bit tricky, huh? Okay, so what are they asking me? They're saying if together they make 28, how much profit does Sheldon make? So I want to for sure have Sheldon as part of it, and I'm going to have to use the total. Okay, so Sheldon's profit and total. Well, it says right here that Sheldon makes $2. And then the next thing should say, okay, so then the total, when he makes 2, then the total is what? But it actually tells me that Leonard makes 5. And you're like, well, that's great. It's not Sheldon to Leonard, it's Sheldon to total. So what do I do with that? Well, this goes together. When Sheldon makes 2, Leonard makes 5. So then what's the total at that point in time? It's 2 plus 5, the two of them together, and that's 7. So when Sheldon makes 2, then the total amount of Sheldon and Leonard is 7 because I just added the 2 and the 5. Then the next sentence says, okay, if together they make 28, so here's the profit of 28, then how much profit does Sheldon make? We don't know. So I'm going to have that be my unknown. Now that I have that set up, I can try to solve my proportion because I'm going to set those two ratios equal to each other. We'll always go towards the direction of your unknown. And 7 times what is 28? 4. So then 2 times 4 is 8. So 8 over 28. So Sheldon's going to make $8 when they have a total profit of $28. And you can see that that ratio of 8 over 28 reduces to 2/7. So I know that those ratios are equivalent. Now the actual answer they said is, how much does Sheldon make? Sheldon makes $8. There you go. Okay, see if you can use that to try and solve this problem at the bottom. It says the members of the PTA are ordering pizza for a meeting. They plan to order 2 cheese pizzas for every 3 pepperoni pizzas that they order. So you would think it's cheese to pepperoni. But then it says how many cheese pizzas will they order if they order a total of 25 pizzas. So actually they want me to focus on cheese, and I'm going to have to use total. Okay, so I have cheese to total. Well, the first sentence says that when you order 2 cheese pizzas, so 2, you order 3 pepperoni pizzas. So then at that point in time, what's the total? You have 2 cheese and 3 pepperoni for a total of 5. Okay, so when you have 2 cheese pizzas, you're going to also have 3 pepperoni, so you have a total of 5 pizzas. Then my next sentence says, okay, so then how many cheese pizzas? We don't know. That's my unknown, my X. Will they order if they order a total of 25 pizzas? So what is the number of cheese going to be if I have a total of 25? Always go towards the direction of your unknown. So 5 times what gives you 25? 5 times 5. So then do the same thing up top. 2 times 5 is 10. So when you have a total of 25 pizzas, you're going to order 10 cheese pizzas. Okay, let's go ahead and try some more of these. So if you turn the page, Let's go ahead and look at this one right here. Now, one thing is that the most common thing we like to do with proportions is use it to represent maps, because we obviously can't make a map be the actual size that something is. Because think of already a map trying to fold it. Can you imagine if it was actually the size of a state or of the country, or of the world? How in the world could you like even hold that piece of paper? So we have to do what's called scaling things down. Okay, so a scale drawing is a drawing of a real object that's proportionally smaller or larger than a real object. And you're like, well, when is something larger? Think about like molecules inside of our cells. Okay, they're so microscopic. So how do we know the different parts? So we would then scale it up so we can see the different parts that make up our molecules. But if we're talking about maps and things, obviously then we're scaling it down. And when we're making buildings, or planes or cars, we scale those things down. Okay, so right here, I'm going to look at this map, and usually somewhere on there, either at the top or the bottom, they'll give me what's called the scale. So 1 inch on the map is equal to 2 miles in real life. So I like to always do the actual distance to the map distance, or it doesn't matter if you do map to actual, just as long as you're consistent. Okay, so since we wrote actual to map, I'm going to write down the scale that 2 miles in the real world is going to be 1 inch on the map. So then they said the distance between two schools on Lay Avenue is shown on the map. What is the actual distance between the schools? Okay, so if you look at Lay Avenue right here, you have here and here, and then how far apart are those? Well, if you look, it labeled that it's 3 inches apart. So on the map distance, it's 3 inches. So then how many miles is that? We'll always go towards your unknown. So 1 times what gave me that 3? Well, 1 times 3 gave me that 3. So then do 2 times 3, and that is 6. So if it's 3 inches on the map, that means it's actually 6 miles in real life. So these two schools are 6 miles apart. Okay, using that same logic, I want you to try to solve this problem right here. Okay, well, again, always try to pause the video, try it yourself, and then unpause it and come back. Okay, so you unpaused it, you're back with us. I like to always write down what I'm talking about in front. So I have the map, and the map is talking about inches. And then I have to actual. And the actual is talking about the distance in miles. Okay, so 1 inch on the map is equal to 20 miles in real life. And they gave me on the map a distance of 2.5 inches. So they want to know how far are those towns actually apart in real life from each other. We'll always go towards your unknown. So this one's nice and easy. 1 times what is 2.5? Well, 2.5. So then since I multiplied this by 2.5, multiply this by 2.5. Type that into your calculator, and 20 times 2.5 is 50. So that means those two towns, even though it's only 2.5 inches in real life, on the map, in real life, they're actually 50 miles apart from each other. Okay. And that's one instance where you would use scale drawing, is when you're doing a map. Okay, let's try to solve some more of these. Go ahead and turn the page. Okay, and we can zoom in a little. Okay. Up at the top, it says find the unknown value in each proportion. Well, again, if I haven't told you enough, please always go towards the direction of your unknown, right? Okay, so you have 5 times what is 30? Well, 5 times 6. So then do the same thing on top. 3 times 6 is 18. So your unknown is 18. Now, sometimes on like standardized tests, they make you fill in blanks. even though you're like, well, I solved it like this. I know the answer is 18. So in order to get the points, you have to think about what they're doing. Okay, we already figured out that the answer is 18. What did you do? Well, I multiplied 5 times 6, and then I did the same thing on top. I did 3 times 6. Now, why does that actually work out? What they're showing you is that as long as I do the same thing to the top as I do to the bottom, I can multiply this ratio by whatever I want to get an equivalent ratio, because any number over itself is 1, right? 6 over 6 is 1. And if you multiply a fraction by 1, it doesn't actually change its value. So this is just me writing the same ratio of 3/5 in a different way of 18 over 30. This reduces to 3/5 if I just divide both of these by 6. Okay, and so that shows you why I can write these two equivalent ratios equal to each other. Okay, so let's try that same logic here. So they have from here to 5. How I always want to go towards the direction of my unknown. So it's not 5 times 2. It's actually, what do you do the 10 to get to the 5? I'm actually dividing by 2. So then do 4 divided by 2, and you get 2. So 2/5 is the same as 4/10, because that's what 4/10 reduces to, is 2/5. Okay, for these next problems, let's actually show my work on a separate sheet of paper. Okay, so if I take out a separate sheet of paper, let's label that these are actually on page 182. So I'm going to label page 182, and we're going to start with problem number 3. Okay, so on problem number 3, we're talking about Layla and Joe are two of the partners in a business. Layla makes $3 in profits for every $4 that Joe makes. So Layla makes $3 for every $4 that Joe makes. The next sentence says, if their total profit on the first item sold is 105, how much profit does Layla make? And this is where it gets tricky, because initially you'd want to do Layla to Joe, right? But actually, they gave us talking about the total. So I'm going to have to talk about the total, actually. And the other thing they told me about the total is how much profit does Layla make. So I want to focus on Layla rather than focus on Joe. Okay, now I want you to try to set up the two proportions before we go through it together. So go ahead and give it a try. Okay, now you're back with us. Let's see how you did. Okay, so it says, again, that Layla made how much? 3. And when Layla makes 3, how much does Joe make? 4. So what's the total at that point in time? The total is 7, because 3 plus 4 makes that 7, right? Then the next sentence says, okay, well, if the total is 105, then how much did Layla make? Okay, now let's try and solve the proportion. So I always want to go towards the unknown. So let's go towards the unknown. 7 times what is 105? Well, you have a calculator. Try 105 divided by 7. Does it go in evenly? Yes, it does. It goes in 15 times. So let's do 3 times 15, and you get 45. So if the total profit is 105, then that means that Layla made $45. Again, if for some reason it doesn't go in evenly, you can always do what's called cross products. So you would multiply across. The 7 is diagonally across from the x, and set that equal to these diagonally across from each other of 3 times 105. Well, that can't simplify, but the right, if you type in 3 times 105, you get 315. Now to get x by itself, you would divide by 7 because anything divided by itself is 1, and 1 times x is x. Whatever you do to one side, you want to do to the other. Well, 315 divided by 7 is 45. And look at that, you got the same answer. So again, if for some reason you can't figure out what 7 times something equals this, just solve by cross products. Or also, if it gets a repeating decimal, sometimes that's hard to work with. So then you could also use cross products. Okay, let's try the next one. The next one says, move this down. Okay. Henrik wants to enlarge a photo that is 4 inches wide and 6 inches tall. The enlarged photo keeps the same ratio. So how tall is the enlarged photo if it's 1 foot wide? So we're talking about, go ahead and write this down, how wide it is to how tall it is. Well, it said when it's 4 inches wide, it's then 6 inches tall. And you want to keep the ratio of those the same, otherwise your picture is going to look distorted. So whether you blow it up or blow it down, you still want to keep that ratio the same. So they said, okay, what if it's 1 foot wide? Well, 1 foot is 12 inches, right? So if it's 12 inches wide, then how tall should it be? We don't know. That's what we're going to try to figure out. Well, always go towards the direction of your unknown. And how do you get from 4 to 12? You multiply by 3. So then multiply this by 3, and 6 times 3 is 18. So if you make it 12 inches wide, then it has to be 18 inches tall. Otherwise, your picture is going to look funky. All right. Again, if you haven't tried any of these yourself, pause the video, try it yourself, and then unpause it and come back. Okay, number 5 says, a person on a moving sidewalk travels 24 feet in 7 seconds. So we're talking about feet per second. And 24 goes together, so you have 24 feet for every 7 seconds. Well, the moving sidewalk has a length of 180 feet. So how long will it take to move from one end of the sidewalk to the other? Basically, what it's asking is, if you do that rate, how long is it going to take you to go 180 feet? Well, we're going to solve for how long that takes. Always go towards the direction of your unknown. So go towards the direction of your unknown. 24 times what is 180? We'll type that into your calculator. 180 divided by 24. What do you get? You get 7.5. Double check. Does 24 times 7.5 equal 180? Yes, it does. So do the same thing on the bottom. 7 times 7.5 is 52.5. So that means it's going to take 52.5 seconds. That's my answer, in order to go 180 feet. Now, if you couldn't figure that out, remember you could always do cross products. 24 times x equals that 7 times 180. Well, 7 times 180 is 1260. And in order to get x by itself, you would divide both sides by 24, because anything divided by itself is 1, and 1 times x is x. And then on this side, 1260 divided by 24 is 52.5. And x was solving for seconds. Always double check that where your unknown is, that unit is what they were asking you to solve for. And it says, how long will it take? Seconds makes sense for my answer. Okay, my next one says, contestants in a dance marathon rest for the same amount of time every hour. A couple rests for 27 minutes in 6 hours. How long does a couple rest in 8 hours? So what are we talking about here? Because you're like, there's 2 times. So let's be specific. We're talking about the minutes that you rest versus the hours that you dance? Well, it says first off that they rested for 27 minutes when they danced for 6 hours. So then they're asking you, 8 is talking about the number of hours they danced. So then how long will they rest for? Okay, we'll always go towards your unknown. And 6 times what is 8? I don't know. So this one might actually be one where we want to do cross products. So I'm going to multiply the 6 times the x and set that equal to the 8 times the 27. Okay, I can't simplify, but 8 times 27 is 216. Now to get x by itself, I want to divide by 6 so that these cancel and become 1, because anything divided by itself is 1, and 1 times x is x. I can do that as long as I do the same thing to the other side. So once I divide 216 by 6, I get 36. And what's x talking about? The number of minutes rested. So if they dance for 8 hours, they'll rest for 36 minutes. Okay, the last one I want you to solve is using this scale right here. They want to know what's the actual distance between Condot and Montrose. Okay, so if I go ahead and move this over so that we can see. Okay, right here, these are the two cities, and they told me the distance is 1.5 centimeters on the map. So we have number 7 is talking about the map versus the actual distance in real life. Okay, well, they said, how far is it in real life? We don't know, but the distance on the map is 1.5 centimeters. Okay, and if it helps, like, centimeters is on the map. And right here, if I look within the drawing, it tells me the scale at the bottom. They said that 16 kilometers, okay, so the actual distance is in kilometers, which is kind of like meters. It's equal to 1 centimeter on the map. So 1 centimeter on the map is equal to 16 kilometers in real life. Now that I have that set up, let's try to solve my proportion. Always go towards your unknown. So 1 times what is 1.5? 1.5. So then do 16 times 1.5. And what do you get? Well, 16 times 1.5 is, type that into your calculator, 24. So 24 what? Well, this was talking about kilometers because we were talking about the actual distance. All right, my little mathematicians, congratulations. You've now mastered setting up proportions in order to solve word problems.